Hi, Sia Karflis, town resident and member of technical staff to the Water Quality Committee. The environmental analyses that have been done have gone a long way to answering a number of the questions that have been raised about the environmental impacts of discharge to Site 7. And one of the first questions early on that came up was, what about nitrogen going into West Falmouth Harbor? That was a big concern, it was an important concern. And the quick answer, if you will, to that question is there is no nitrogen from Site 7 discharge that's going to go to either West Falmouth Harbor or to Massapaquid Creek, or to William Pond for that matter, because we're not looking at Site 10. Now, that's a quick answer, and the question really is, how do you know that? And that's going to take me a few more minutes to explain. So the way that this determination was made is through groundwater modeling. GHD is the town's consultant. They were hired to put together a technical memorandum on the flow of groundwater and how it would move once you started loading 260,000 gallons of water onto Site 7. We already knew from the Mass Estuaries Project reports that Site 7 was not in the watershed delineation for West Falmouth Harbor. So initially, we knew it was not in the West Falmouth Harbor watershed, but things change when you start loading water. So GHD hired a company called Applied Hydrogeologic, or Analytical Hydrogeologic. And Analytical Hydrogeologic has created, in previous years, a model called the West Falmouth Harbor groundwater model. That model has as its foundation the USGS models, the USGS groundwater models that have been used for all of the MEP reports. The Mass Estuaries reports are based on the USGS model. It's called the Sagamore lens, and it's a macro scale for where the groundwater flows in this area. So what Applied Hydrogeologic did for the West Falmouth planning purposes for previous studies is took field data. They enhanced that larger scale model with very specific data from surface water features, from flows, water flows that they had calibrated, and from elevations, so actual ground truthing of elevations. And they came up with the West Falmouth Harbor model, and they used that model to add particles, add groundwater, add flow to Site 7, and watch where the particles. It's called fate and transport. So fate and transport shows from this that there are no particles going into either West Falmouth Harbor or Massapaquid Creek or Wing Pond. Now, so we've got a tech memo 12, that explains that there is no nitrogen going into these water bodies. Buzzards Bay Coalition hired a consultant to review this. So in addition to having a model that we understand that is rational and vetted, we have Buzzards Bay Coalition's consultant, that is, of course, the Witten Group, taking a look at this and saying, you could do some sensitivity analysis to confirm the results of the study. So Horsley Witten Group got together through the town with GHD and Analytical Hydrogeologic and defined some parameters. So these parameters have been defined by Horsley Witten Group and Buzzards Bay Coalition. They are intended to confirm the technical memo. The scope of work has been written, so we know exactly what we're going to be doing. The notice to proceed has gone out so that the formal work and a formal additional tech memo can come back. And the preliminary results are that with that additional reverse particle tracking, there is still no flow going into Massapaquid Creek, because that was the concern. That we don't see anything going into West Falmouth Harbor, it's not seeing anything going into Massapaquid Creek. Want to be extra sure about Massapaquid Creek, run a sensitivity analysis with a reverse particle track, and define a watershed. So there's been a lot of attention. This was not look at the report, put it on a shelf, say, sure, we're not going to have a problem. It was, let's look at the report, let's understand how good the model is that gives us the answer that we got, and then let's review it again with an additional sensitivity analysis to confirm it. So that's what we have to say about West Falmouth Harbor so far, and the lack of nitrogen going into it. So the other concern, the second concern, was there are other wetlands and water bodies that are downstream. And so just to show you where we are here, this is 28, this is Site 7, there's Crocker Pond, and what we have is groundwater flowing in this direction. So we've got two main, I'm sorry if I got my back to you guys, I'm just going to do this for this particular slide. We've got an old Silver Beach wetland system, and we've got an Anasket Road wetland system. And so these two wetland systems were reviewed, and Buzzards Bay, here's our favorite bay, Buzzards Bay, and the results of that environmental study that the town hired out to do was that there were no impacts to either Buzzards Bay or these two wetland systems. Easy to say. Why do we say that? Well, we say that because we hired SMAST, the UMass School of Marine Science and Technology. SMAST are the authors of the MEP reports that are the basis for all of our TMDale, all of the maximum daily loads, all of the environmental regulations. All of what we do to protect water bodies come out of reports that SMAST does. So they have been looking at wetlands and effects of nutrients in wetlands for decades. So SMAST was hired to look at these two wetland systems and Buzzards Bay and to make a determination if we should be concerned. And the first thing they found that I think is fascinating is these are predominantly freshwater systems. From the biota, from the salinity, the lack of salinity, and from a look at the basins, they are freshwater systems. They're not estuary systems, and they don't support salt marsh components. So SMAST in their report, and I quote, says, wetland areas within the Old Silver Beach and Mascot Road wetland systems are unlikely to be negatively affected by the discharge. They say that because they're predominantly freshwater, and they say that because they already have organic matter that will take up nitrogen, and the plants that are already there are able to take up the nitrogen. And in the report, which is called Coastal Downgradient Impacts, you can see the quote, and it's also on our website, they go through their determination of why they are not looking at these two wetlands as potentially being impacted. And they also call the load from Site 7 to Buzzards Bay insignificant. I didn't make up that word, they used that word. And they use in their report a number of comparative analyses. So if you look at loads coming from other places, in particular the load from any of our harbors along the western side, the load from this is 2% from any one of those. So they felt that it was a real de minimis amount. And Buzzards Bay itself is not guided by a TMDL. So I guess for those reasons, we're looking at those wetland systems and not worried that there's going to be an adverse negative environmental impact. The third place that we started looking and doing these analyses was where the groundwater goes and does in fact intersect Crocker Pond. So this data comes from GHD's Technical Memorandum 12, so you know where the numbers come from. But the 42% is what is calculated that will flow through Crocker Pond as it comes down from Site 7. Now, we were asked at the last time we were here what the margin is. So I want to point out a couple of things. This 42% is actually a worst case scenario. And I say that because when you look at the particle tracking and you look at the depth of Crocker Pond, where the particles are intercepting, it's the shallow part. And there is a possibility, probably a likely possibility, that some of the particles from the groundwater are actually going to go underneath Crocker Pond. So all of that 42% of groundwater is not going to go in and out of Crocker Pond. It's going to go under it. But we weren't trying to split hairs, and we weren't trying to take credit where we didn't need to, so this we looked at as a worst case scenario. All of the particles that flow through, stay in, and go out. None of them go under. The other, and I think this is fairly significant, is that the nitrogen concentration increase that was calculated was based on the 3 milligrams per liter that come out of the wastewater treatment facility. Now, 3 milligrams per liter is state-of-the-art treatment for wastewater treatment facility. And the reason 3 is the bottom number that you can engineer to is because once you start getting to these levels, you get a fairly significant percent of what's called refractory nitrogen. That is nitrogen that the microbes that are working to nitrify and denitrify, they can't get to it. It's not bioactive. And so at our wastewater treatment facility, about half of that 3 milligrams per liter is considered refractory nitrogen. The analogy is if you have a room full of hungry people, and I'm hoping I'm not getting everybody where they live right now, but if you have a room full of hungry people and you put out a plate of fruit or cans of soup. People are going to go for the fruit first. And they're only going to go for the cans of soup if they're absolutely needing it. And so that's what happens with microbes. And this refractory nitrogen may be bioactive, but in many ways it's really not if there's any other nitrogen around to be eaten. So this increase is about 50% higher than is probably ecologically what's really going to happen. SMAST says quite definitively in a number of their reports, including the reports they did for the two downstream coastal wetlands, that nitrogen is not a limiting factor in freshwater water bodies. And so with these considerations, we are looking at nitrogen not being the problem in Crocker Pond. Now, nitrogen goes into Crocker Pond and flows out of Crocker Pond, and also from Crocker Pond, a small amount, less than 4%, goes into Herringbrook. And so this 3.7% is not going direct from Site 7, but it's going into Crocker Pond and then going into Herringbrook. And that 3%, that amount is less than 4% of the total watershed load. So it's actually a very small fraction of the nitrogen coming in from all the other sources going into Herringbrook. So that's the story on nitrogen.